Hello, my name is Zakhidov. I am professor of physics, material science in University of Texas at Dallas and also the scientific leader of Samarkand Quantum Center in Uzbekistan. So today I want to introduce very shortly what we want to do in our project, which we are submitting for Google competition. So, the title of our project sounds extremely simple. Quantum Carbon Cleaner. And motivation for this project is absolutely straightforward. We will try to solve it and exemplify it on the one city in Uzbekistan surrounded by industrial cities like Cherchik. It's a big chemical city very close to Tashkent. And it's huge pipes. They keep generating orange clouds of NO2, CO2, and particles of carbon, which create heavy smoke around Tashkent. It creates air pollution. It causes allergies in 5 million people living in the capital of Uzbekistan, Tashkent. Also, the winds bring dust from the Aral Sea, which has dried several years ago, and the dust brings all sorts of minerals, which are hazardous for health. So, Tashkent is in front of natural disaster, and we want to solve that problem. And the way to solve it is extremely complex. So let me show you what we basically want to do in a very simple approach, not going to the details. I will go to the details. So what we want to do, we want to extract CO2, NO2, carbon particles, dust, and use ultimate catalyst, which is not created. We want to create it using quantum algorithms. And we want to enhance thousands times, maybe 10,000 times, the catalytic activity of this magic ultimate catalyst. We envision it as some sort of quantum dots or metal organic frameworks, which we will model using, again, quantum computers with quantum algorithms. Then we have an engineering device, which we call catalytic converter. Like in every car which you are driving, at the bottom there is catalytic converter. So the gases inside catalytic converter, they interact with the catalyst and split all the bad stuff into clean oxygen and carbon, which can be collected. So 5 million people are going to have nice clean air. That's what we want to do. And now I want to show that this is very hierarchically complex task, because it has different levels, different scales, which we want to model. We start from the smallest scale, one single atom. There are over 100 elements in the Mendeleev table. Using math, and we have mathematician in our team, and combinatorial approach, we choose those elements which are most useful to be ultimate catalyst. Anyway, I am going to describe that in more detail on the diagram that I will show you next. Thank you for the first part.